Hello, my friends. This is the part 3 of DIY robotics. In the part 1, I have built the structure, the pen and tilt structure with a Raspberry Pi on top. In the part 2, I have explained the concept of robotics, electronics, the Raspberry Pi, computer vision AI, OpenCV library, and I've explained the PWM, pulse width modulation concept. I have explained as well the structure of the Raspberry Pi for this exercise, for this capstone project, how I connected the camera with the pins, mainly on the pin 11 and pin 12 for pan and tilt. So if you didn't see the first two videos, please go ahead and go through the first two parts. In this part, the first exercise I'm going to show you is how to control the pan left and right from 0 to 180 degrees. And the second exercise, I'm going to show you like how to control the tilt up and down from 0 up to 180 degrees. And finally, we're going to combine both Python programs into one. We're going to make a generic servo control Python program where we can give a command and we can command the Raspberry Pi to turn the structure up, down, left and right, so we can control the two servos in one Python program. So let's start. In this first line here, we are starting the Python program by simply importing the RPI GPIO module, and we are calling it, so that's why like you see import RPI GPIO. The Python will know like how to import that library, and we are giving the name GPIO for this simply for this module that we are importing. And GPIO stands for general purpose input and output. So this is where we're gonna I'm gonna show you how to access the pin, and in order to access the pin, the Raspberry Pi general purpose I/O module has to be imported. I'm importing another library that I need. It's the time, and this library is actually, as you see, like I'm gonna use some sleep. I want to stop the processing so I can show you like when I'm moving this the pan or tilt left and right. I want to stop it and show you like the position where it stopped. So I need to freeze the program for some seconds, and that's why I'm using this time module. So that are the two libraries I'm just like importing. Now it's important as well that in the third, what you see, there is the GPIO set mode. And this set mode actually, it has two modes. The board, as you see, like I'm using the board, BCM or board. I'm not going to talk about the BCM. I'm using the board here. So again, if you go back to the part 2, you're going to see the board numbering of the pins. It's very important to tell you like that the pan itself, I'm using the pin number 11. This is where I have hooked the wire, the PWM wire of the pan on the pin 11. You can see it in the video number 2. So this is where I'm telling the Python that, by the way, GPIO.setup, I'm doing a setup for the pin 11 as an output pin, and this is where I'm telling like the Raspberry Pi that the pan servo is actually on the pin 11. Okay, so if we go to the next line, the GPIO the PWM 1150, what does that mean? Like it's just to say like I'm having the pan servo, so I'm creating a variable called pan servo, and I'm passing in that variable the GPIO.pwm. I'm passing the pulse width modulation on the pin number 11 with 50 hertz pulse. And if we go and continue down, we're starting the modulation with a 0 millisecond, or just to say that we are not passing any pulse. It's just like 50 hertz pulse, but with 0 modulation. Then I'm making the system freezing for 2 seconds. So that's why I'm using the time.sleep2 for 2 seconds. Then this is where I'm start like setting the servo angle to different, or the duty cycle. We are not talking about angle now. I'm gonna show you like at the end of this part how to convert a duty cycle to an angle. But for now, like in order to move the structure, to move this pan, and remember the pan is the servo moving the structure left and right. So in order to move it, I need to pass uh, some modulation in a millisecond. Please refer back to the video number 2 to understand what I'm saying about what I'm talking about. So here, as you see, I'm changing the duty cycle. So we're starting with 0, then I'm changing to 3. So I'm passing a modulation with a duty cycle 3 millisecond. And it's, if you observe, like you can start typing different duty cycle and you can observe the angle, whether it's 0 degree or 80 or 90 degree or 180 degree. So I've done multiple, I changed the duty cycle to multiple numbers, and I've noticed like that the duty cycle number 3 is actually the 0 degree. And if you see down, so after changing the duty cycle to 0 degree, or starting with 0 degree, I'm sleeping, or not me, but I'm making the Python program sleeping for 1 second. Then I'm changing the duty cycle from 3 to 8. And then this is making the servo rotating to 90 degrees. Then I'm making that program sleeping for 1 second. And then making it from duty cycle change from 8 to 18, which making actually the servo, the pan servo rotating to 180 degrees. And then sleeping again the program for 1 second. And finally going back to the 90 degrees, then going back to the 0 degree. So to summarize, we're going from 0 to 90 to 180, then going back to 90, then going back to 0. And then each time we are making the program sleeping for 1 second. So let's run this and let's see if you take a look at the camera, like where I'm showing the servo, you will see how it's going to move. Start the position that's starting with 0, then going to 90 degree, then 180 degree. So as you see, 0, 90, 180, 90, 0. So I'm going to run it one more time, starting with 0. So 0, 90, 180, 90, then 0. Next, I will do the same, but with the tilt servo. Okay, so now we're going to do the same exercise, but as you see, like the pan, we are using the 11 pin, or pin number 11. Now, the same thing that there's another Python already, I wrote this Python program where I'm using, again, the same library. I'm using the same GPIO module, importing the GPIO module, importing the time, and it's the same what I've just went through. The only thing that's different is the pin number. It's number 12. So the tilt servo is actually on the pin 12. And again, you can go back to the second video and see how we have connected those two servos to the pin 11 for the pan and the tilt on 12. And as you see down here, I'm just saying like the tilt servo, it's the GPIO.pwm 1250, so I'm passing the 50 hertz signal on the pin 12 as an output pin, and I'm starting with 0 duty cycle, then changing the duty cycle up and down. So you see I'm starting with putting the tilt servo, pushing it up, so moving it up to the maximum. And I found that just by going to duty cycle 5 to make it up. Then if you want to make it straight, I've noticed that the duty cycle should be 10, and this was done by trial and error, so you can play with the numbers so you can see and match it. Like this one should 5 is equal to almost 180 degree, 10 straight, meaning 90 degree, and then down almost zero, it's 14. The duty cycle is 14. Going up, then going straight, then going down. And at the end, I didn't mention that previously in this pan servo test, but the pan servo test has the same. We have to do the cleanup at the end. So after passing the PWM on the pin 11 or pin 12, depending where we're going, like pan or tilt, we need to do the cleanup at the end of the program. And the cleanup is actually, we have to stop. So when we talk about the pan servo or tilt servo, we have to run the stop command to stop the PWM, the pulse. We have to do a GPIO cleanup, so it will clean, as you see, like the description here. It will do the cleanup for the pins, and then it's just like I'm printing goodbye. It's not necessarily, but those are the main commands to make sure that the pin are not getting the signal anymore when we finish the program. So let's run it, and if you take a look at the camera showing the servo, I'm gonna run it now. So as you see, it went up, straight, down. So I'm gonna run it one more time. Going up, straight, down. Thank you. I will go next to the compiling those two pan and tilt into one program. So let's move to the third part of this video. Okay, so now we are going to switch to the third program, compiling both the pan servo test and the tilt servo test, the two programs, the two Python programs into one program. And before doing that, I just want to show you some concept here. As you see, like on this screen here on top, on the left, we have the duty cycle concept. This is how the Python, as you have seen, like in when we were like moving the pan and tilt, we were using the duty cycle to move it like from certain angle to another angle. And because as I mentioned, like the Python or the PWM Raspberry Pi, it does not understand the angle. It understands the duty cycle, which is like, again, how many milliseconds the pulse should be going. So in order to make it more human, something that readable by a human or a human can understand better or can control better, we want to make sure that our program, final program, it accepts the input, the angle as an input and not the duty cycle, because as a human, I would know more like I want to move this structure up, like 0 degree up or 180 degree up. I want to move it left, 10 degrees left. So as a human, I would be understanding more that the angle instead of using the duty cycle. And that's why I need to convert a duty cycle to an angle. So when I was doing that exercise, I've seen, if you remember, like shortly, like when I was talking about the tilt and servo test, I used the duty cycle starting from 3 up to 14. So here up it should be 14. So that DC or duty cycle was varying from 3 to 14, while on the right, the angle was going from 0 to 180. So the duty cycle and angle, it's a linear relationship. And that's why, like, as you see, going like, so from 3 to 13, 0 to 180, if we do the linear relationship, we can use, like if we are using some mathematical linear equation, if I'm subtracting duty cycle minus 3 divided by 13 minus 3, so the maximum minus the minimum, it's equivalent to the alpha. Alpha is actually the angle, which is a variable, minus 0 because I'm starting from 0 up to 180. So alpha minus 0, which is my DC, my equivalent to DC in angle unit, divided by 180, which is the maximum minus 0. So doing that equation and simplifying that equation, you will see that in red, this will be the equation, mathematical equation that we can use to convert a duty cycle to an angle, or angle to a duty cycle. So here I'm saying like duty cycle is equal alpha divided by 18 plus 3. And simple math, if I want to know like what would be the alpha compared to a duty cycle, the alpha will be 18 multiplied by DC minus 3 if I'm moving the 3 to the other on the left. So this is how I can identify the duty cycle based on the angle, and how I can identify an angle based on the duty cycle. So if I'm going to move back to my program here, and this is my Raspberry Pi I'm in, I'm going to go to the third program, compiling both. This program is making my test very generic, and it's using the angle instead of the duty cycle. So in order to do that, again, I need to import the time, because I want to make this program sleeping when it's taking a position, changing position. What I'm doing as well, I'm importing the Raspberry Pi general purpose I/O, setting the mode to board, set warning to false, and then I'm creating a method in Python called setServ or setServoAngle. So the servo, it can be either pan or tilt. So I want to pass, I want to use the servoAngle method, where I'm going to pass at two parameters. The first parameter is I want to tell Raspberry Pi that, by the way, I want you to set an angle for a pan or tilt. So that's why the servo, you see, I'm putting if condition here. It can be either a pan or a tilt. And if it's a pan, I'm using the pin number 11. So this is where I'm telling the Raspberry Pi that if I'm passing here the value pan, then consider the pin, because I'm connecting the servo pan to the pin number 11 as per the board, the numbering. And otherwise, like when the servo is not pan, it can be tilt. In this case, I can pass tilt, so it's not pan. Then take the servo pin as 12. Now the first part here that I skipped, we're gonna see it later in the next part of the DIY. I'm just saying to the Raspberry Pi that if the servo is pan, I want to make sure that assert if angle is more than 0, or actually another way, I wanted to make sure always that the angle is more than 0 and below 180. So I want to go in the range of 0 up to 180. This is for the pan, left and right. So I want to go from left 0 up to 180, but it cannot go down as well more than 60. So that's why I'm saying it has to be between 60 and 180. Those numbers, again, it's by trial and error. You have to check your structure. It depends on your structure. You can tell Python like what is the range, acceptable range that you want your servo to play with. And if an angle given, or if you are outside of the vision, that condition here, it's going to give you an error. So it will not, like, you can catch that error and make sure that it's not doing anything. So to continue here, when I'm passing to the set servo angle, the servo, which is a text pan or tilt, I'm passing as well the angle. And the same what I've done before, I'm telling the GPIO, I wanted to set up the servo pin, which can be like either 11 or 12, depending on if I'm passing pan or tilt. And I'm telling like I want to configure that pin to be an output pin. And then I'm passing the 50 Hertz signal, starting with 0 modulation. And then this is where I just show you like the equation. The duty cycle is equal to the angle divided by 18 plus 3. So this is where I'm passing an angle in my method, and I'm converting. So I'm as a human, I will know like I want to go 90 degree. Now, as a Raspberry Pi does not understand the angle, it understands the duty cycle, and that's why I'm using this equation that I've just like shown you. How did I come with that linear, based on the linear relationship, how did I get that relationship between duty cycle and angle? So this is how, this is the equation itself. So this is how I'm calculating the duty cycle based on the angle, and I'm telling the PWM to change the duty cycle based on the calculated value. So when I'm starting this program, I'm passing the two values, the servo, pan or tilt values with an angle. And so I'm catching, like, when I'm gonna write it down here shortly. This is where I'm getting the first argument, and then this will be the first argument is going to be the servo itself. The second argument, I'm transforming this to an int because it will be the angle itself, and it will turn it. Then I'm doing the cleanup. So let's see. I'm going to pass some comments now shortly, where I'm going to show you, like, randomly. I'm going to put numbers, go up, go down, go left, go right. So let's see it. Okay, so running this program by itself, it's going to give an error simply because I didn't give him. So I ran the Python 3. This is my folder, and this is where the Python program Servos CRTL, the one I'm just showing here. So when you run it, it's trying to get the first argument and couldn't find it. And because it couldn't find it, like, it's out of range error. So if I'm running again the same, but this time I'm going to add the two arguments, as you see in the command line below. So I'm going to add the word pan, and then I'm going to say 90. So I want to move the pan 90 degree. If you look at the servo, the camera showing the servo, just press enter, it went 90 degree on the right. So again, if I want to make it 180 degree, so I'm changing the argument number 2 to 180, and it went 180. I want to give it back, push it back to 0, so it went back to 0. Now, if I want to give it command to the tilt, so instead of pan, the argument 1, I'm going to pass tilt. Let me start with 0, and let's see what will happen. So if you remember, like, I put some assert statement on top that I would be only accepting the angle from 60 to 180. So 0 is out of the range, and that's why I'm getting this error. So in order to fix it, I need to make sure that, and this is where the assert is telling me, like, your angle should be between 60 and 180. So for the tilt, my angle should be at least 60. If I'm putting 60, and let's see what will happen, it went up. Now if I'm putting like 180, it went down. 90, it's almost straight. Go back to 180, 120, then go back, instead of tilt, I'm going to show pan. So pan 120, $80. If I want to make it straight, I think it was 90 degree, 0 degree. Let's put it 10 now, 20, and put it up, tilt. We're going to put 60, it went up. So this is just like to show you randomly how I'm controlling now in one program, up, down, left and right, the servo, the two servos, by passing. And as you see, like, it's a very simple program, not that complex. And why I'm doing this, because you're gonna see it in the next video, in the part 4. Thank you very much. I hope you enjoyed this, it's not short one, this video. Thank you very much.